Hey Algebra 1 students, this video is for section 9.1, so you will need your Algebra 1B chapter 9 note packet. And we're going to start right on page 2. And at the top of page 2 is a warm-up. So what I would like you to do first is to pause the video and complete the warm-up. So hopefully you have paused the video and completed the warm-up. I'm going to give you actually the answer first here. 26x squared minus 32x plus 8. So these are review problems. This problem number 1 is from chapter 7. So this is a multiply because you don't see an add or subtract symbol between the binomial and the trinomial. And most of you, I believe, are using the box to do this multiplication. So you need a 3 by 2 box and put your polynomials that you're multiplying outside the box, and then we're going to do the multiplication to fill in the middle of the box. I recommend you put these invisible ones by these exponents so you remember to add the exponents. So 5 times 2 is 10, x squared times x to the 1 is x to the third. 5 times 6 is 30, x to the 1 times x to the 1 is x to the second. 5 times 4 is 20, 1 positive and 1 negative, and it's actually negative 4 times 5x, so we have an x there. 1 positive, 1 negative gets us negative 4x squared. So for this one, there's no x down here, so we're just multiplying negative 2 times all 3 of these terms. So this would be negative 12x, and 2 negatives make a plus 8. And then we bring the answer out of the box and combine like terms. Remember, if you check the diagonals often, but not always, your like terms will be right there. So 10x to the third, there's no other x to the third, so nothing to combine with that. 30 minus 4 is 26, and that would be positive because I have more positives than negatives. So 26x squared. Negative 12 plus negative 20 is a bigger negative, negative 32x, and nothing to combine with the 8. So that was a chapter 7 problem. This one is a chapter 8 where it's asking us to solve, which means we're finding the zeros, which means we're finding the points where y is 0, we're finding the x values. This trinomial does not have a greatest common factor, so I would solve this by factoring. And I don't have a GCF, so I would do X box. There's my A, B, and C. Top of my X goes 40, A times C, B on the bottom. I'm looking for two numbers that multiply to give me positive 40 and add to give me negative 13. That would have been negative 8 and negative 5. So those are the numbers I'm using again. A is 1, so I don't need to do the box. So my factors would be x minus 8 times x minus 5 equals 0. 0 product property, ZPP, says two factors multiplied together that equals 0. That equals 0. Either the first factor equals 0 or the second factor equals 0. So solve both of these, and I get one solution of x equals 8. And the other solution, x equals 5. And remember, you could also write these as coordinate points because you're finding the x when y is 0. Here's a picture that helps you remember. These are solutions. X-intercepts is one name for them, or zeros. So we are going to look at these again in chapter 9, not in this video, not in section 9.1, but further on in the chapter. We're going to look at other ways of finding the zeros other than factoring. But before we do that, we have to learn the chapter 9 lesson. So we're going to start with some vocabulary. This right here is called a radical or a radical expression. So it's got this radical symbol, they call it. This little number here is the index. The number under the radical symbol is called the radicand, and the whole thing all together is called the radical. You've probably seen it more with just no little number here and a number under here. If there isn't an index shown, if it's an invisible index, that index will always be 2. But it is not written. So when you see the plain old radical symbol, that is an index of 2. So what we're learning in 9.1 is simplifying these radicals. So what we first want to do is break down this number into prime numbers. So basically we're going to do a factor tree on this number until we have all primes. So finding the simplest form is when you break down the radicand, or I guess you could say radical. We're simplifying the radical. So break down the radicand into prime numbers or factors. And the process of doing that, we are going to call jailbreak. You'll understand why when we do an example. So again, in the video, if you ever need to, pause it and fill in your notes. Make sure you get all this in your notes. Now, the other vocab we need to use for the second part of 9.1 is what is a like radical? So a like radical is a radical with the same index. So that's this little number, or the invisible 2, and same indexed and same radicand. So that's the number inside the radical. So this has to be the same and this has to be the same. So radical with the same index and same radicand. A couple examples of that would be square root of 4 and square root of 4. Let me slide this up a little. They both have that invisible index of 2. And the number inside the radical are the same. You can see that 4 and 4 are the same. This would be called a like radical. Another example could be a third root. So we call this a square root when the index is a 2. When the index is a 3, we call that a third root. So this has the same index. So in this case, your index is a 3. And then the number inside the radical also match. So both of these would be like radicals. Let's look at the first example, and then we'll probably do another video. So this first example, we're going to go through this jailbreak process, which is the method we use to simplify a radical. So jailbreak is the method for simplifying a radical. So it says step 1, make a factor tree using prime numbers. So we want to do a factor tree until we get down to all prime numbers. Now remember, prime numbers are numbers that the only factors they have are the number and themselves. So 2 is prime, 3 is prime, 5 is prime, 7 is prime. So what is true about prime numbers? They only have 2 factors, 1 and themselves. So those are your prime numbers. And we're going to do it just like they did here. We're going to start by dividing by 2 or dividing by 3. So square root of 24 can be written as the square root of 2 times 2 times 2 times 3. If you put 2 times 2 times 2 times 3 in your calculator, you'll get 24. So these are equivalent. It's just a different way of writing them. So then it says step 2, circle the numbers who have escape partners. So see these double twos? I would circle those double twos. And then it said, remember, escape partner dies in the escape. So here's the deal. The radical symbol is a jail. You need, in this case, partners of 2, because your index is a 2. You need 2 people to plan an escape. So these 2 numbers would escape. However, only one of them makes it out alive. So you can see this 2 that is now outside the jail is the one partner that made it out alive. This 2 and 3 never had a partner, so they're stuck in the jail. There they are. So the 2 and 3 are in the jail. These 2 2s escaped, but only one made it out alive. And then step 3, it says simplify anything inside or outside the radical by multiplying. So this 2 is the only thing outside the jail, so that stays outside the jail. The 3 times 2 that was stuck in the jail, you'll multiply those together. So this is a fully simplified radical. So this is equal to the square root of 24. Square root of 24 was not simplified. 2 square root of 6 is simplified. All right, let's try one. So here's your first example. So step 1 is make the factor tree. So I'm going to put step 1. We're going to make a factor tree. And how we're going to start these will be the same for all of them. I say grab your calculator, clear it. We're going to put in 140 divided by 2. So check divide by 2 first. It's 70. If you get a nice whole number, then go, okay, 2 times 70 gets me 140. That 2 is prime, so I'm going to underline it. Now I'm going to try divide by 2 again. 70 divided by 2. I'm just going to keep dividing by 2. Okay, that's 35. So I'm going to say 70 is the same as 2 times 35. 2 is prime, underline it. All right, 35 divided by 2. So I get a decimal. I only want whole numbers. So now I'm going to try 35 divided by 3. If 2 doesn't work, try the next number, 3. Oops, I did times. Do 35 divided by 3. And I get a decimal. That's okay. I'm going to try 35 divided by 4. Nope, that's a decimal. I'm going to try 35 divided by 5. Oh, that gets me a whole number. And I notice it gets me 5 times 7. Both of those are also prime numbers. So all of these numbers are prime. So this is the bottom of my factor tree. So I want you to get in the habit of underlining all those prime numbers. Notice I'm not underlining these. Any number that you factored further, you can think, I'm going to cross that off and ignore it. This is what I want. I want all the prime numbers multiplied. So that's step 1. Step 2, and remember, pause the video if you need to. Make sure you have this whole factor tree. I'm going to say 140 is the same as 2 times 2 times 5 times 7. So again, these are all prime numbers. If I put this in my calculator, 2 times 2 times 5 times 7, I get 140. So that's a way you can check also to make sure you factored it correctly. Okay, now we're going to do our jailbreak. This is the jail. These 2s, there's 2 of them, so they have a partner. So they can escape, but only one makes it out alive. So I want you to use this method where you circle your doubles, put your arrow, and write the one that made it out alive outside the radical. So now let's write what we have. We have the 2 on the outside, this 2. This 5 and 7, anybody who's stuck, I like to put a squiggly underline under them. So I know that anybody who's circled is no longer in jail. Anybody who has a squiggly underline is stuck in jail. So these 2 escaped, so they're not in the jail. The 2 that are left in the jail are the 5 and the 7. So that's step 2. Now step 3 said any numbers outside the jail get multiplied and any numbers inside the jail get multiplied. So I'm going to do step 3 over here. So outside the jail is the 2. Nothing for it to get multiplied by. It's the only number outside the jail. Inside the jail is 5 times 7, which is 35. So this is my simplified radical. So again, that's equivalent to the square root of 140. Square root of 140 was not simplified. Square 2 times the square root of 35 is simplified. Okay, I think I'm going to stop this and put example 2 in my next video.